Hi, this is Adrian from Live to Learn Academy, and today we'll be going over lesson 3.3, characteristics of families of functions in factored form. For those of you guys who are interested in tutoring and have been following along with this channel, I noticed that some of you guys are not subscribed, so if you could please subscribe to this channel for more videos like this, that would greatly help our channel grow. If you're somebody who's looking for tutoring, feel free to click the link in our description where you can get in contact with our team to get tutoring for this course, Advanced Functions. But without further ado, let's get straight into it. So guys, before in the previous lessons, we were talking about polynomial functions. And polynomial functions kind of looked like this, in this form. They followed this kind of form. This is a B, by the way, not a 6. Let me just erase that, make it a B. So polynomial functions look like this. Now, when we talk about polynomial functions, this is actually standard form, okay? This is called standard form. Now, sometimes we may get polynomial functions in factored form. And if they're in factored form, they're going to look like this. Now, the process of factoring from standard form to factored form is a different process. We'll get to that later in these units. So those processes are called synthetic division and long division. We'll get into that in a later chapter. But for this lesson, we need to know how to interpret these functions when looking at them in factored form. So there's a couple things we need to know, and there's patterns that we need to follow when we look at them in factored form and we look to graph them. So one of the things we have to know is the different types of functions or the characteristics. So sometimes we may get a factor that's degree 1. So this will be the degree of the factor. The other thing we need to look at is what is the pattern at the x-intercept of this factor. Okay, because remember, all the factors are x-intercepts. This is something to know. All these factors are x-intercepts of the polynomial function. So when we're graphing these, the reason we factor them is so we can find the x-intercepts. But now that we know the x-intercepts, we need to know what the pattern of the at the x-intercept is. So this is where it gets a little interesting. So the pattern of this would be a line. If it's x squared, the pattern would be a quadratic. If it's x cubed, I'll just put these a little closer. If it's x cubed, the pattern would be a cubic. If it's x4, the pattern will be a quartic. And if it's x5, the pattern will be a quintic. So these are just the pattern names. But how do these patterns actually look like? This is how they're going to look like. If we have a graph, and I'm going to do this 5 times so we can see how these patterns actually look like when we graph these functions. So I'll just put them over here for you guys. And guys, this is a great thing to even copy in your notebook because it's kind of like a cheat sheet. This is really going to help you guys understand these kinds of questions. So let's say we have a function, and let's say the x-intercept is here. If the x-intercept is here and it's a degree 1, what it's going to look like, the function is just going to go straight through this x-intercept. So I like to call this function, the line function, a straight. So the pattern is straight. It goes straight through. But how does this differ when it comes to a quadratic function? If we have a quadratic function at this x-intercept, it's actually going to bounce off. So quadratic functions, they bounce at the x-intercept. So you see how, depending on the degree of the function, the pattern of how it interacts with that x-intercept is going to change. So if it's a degree 1, the line will just go straight through. If it's degree 2, it's going to be quadratic, so it's going to bounce off that x-intercept. But what about if it's a cubic function? How will it look at this intercept? It's actually going to do something like this. So you see how it's like a little swivel. Now these are words that I'm making up just to make you guys understand this a little easier. Cubic functions, they swivel at that x-intercept. So the pattern is different. And what about a quartic function? A quartic function is degree 4. Now degree 4 is similar to degree 2 because they're both even degrees. But a quartic function, it's going to bounce, but it's not going to bounce directly off. It's going to be a prolonged bounce. You see how this bounce right here is different? This bounce is different from this bounce. The quadratic bounce bounces directly off, kind of like a ping pong ball. It just bounces off that point. But the quartic bounce is more so along the lines of a prolonged bounce. It hits the x-axis, it stays there for a little bit. You see, it stays there for a little bit, and then it bounces up. So this one, I like to call this a prolonged bounce. And in the same way, we have a bounce and a prolonged bounce from a quadratic to a quartic, or a second degree to a fourth degree. The same kind of thing happens from a cubic to a quintic. So from a third degree to a fifth degree, the same kind of pattern happens. But instead of a regular swivel, it's actually a prolonged swivel. So notice how this prolonged swivel is different from the regular swivel. It kind of sits at that x-axis a little longer. And so on and so forth. So the main kind of patterns, guys, you got to understand in this chapter is straight, bounce, swivel, prolonged bounce, prolonged swivel. So if we follow this pattern, then a 6th degree function would be a bounce as well, but it's going to be an even longer prolonged bounce because this is following the 2, 4, 6 pattern. But a 7th degree function would be similar to the swivel pattern because it will go from swivel to prolonged swivel to even prolonged longer swivel. So the actual function will sit here longer on the x-axis the higher the degree. Now we can go and we can do infinite numbers of patterns at these x-intercepts, but for this particular chapter, what you want to know is up to degree 5. Up to degree 5 will give you a great understanding of how this chapter works. So if you guys are, in this chapter and you're doing this in school, I want you to copy this chart down into a notebook. This is really going to help you understand the next questions. So let's get straight into some practice problems regarding this. So I took some of these practice problems from the actual textbook itself to help us gain a deeper understanding of how this stuff works. So let's go into it. This chapter, it says, okay, question 1. Match the equation with the most suitable graph and explain your reasoning. Okay, cool. So a couple things we want to look at. So if we look at equation 1, okay, so we'll do 1a. If we look at these are our x-intercepts. So this is going to be an x-intercept at -1, and this is going to be an x-intercept at 3. So the first thing I want to look at is where are my x-intercepts, -1 and 3. So I see, okay, over here we have -1 and 3, so that it could be that. Over here we have -1 and 3. Over here we have -1 and 3. Over here we have -1 and 3 and 5. So automatically I know it's not D because we have an extra x-intercept that we didn't account for. So I have to figure out, now that I know the x-intercepts, I need to know what is the behavior around the x-intercepts. So if you look over here, because the first one, the x plus 1, is squared, what does that square represent? That square represents a quadratic, meaning that at -1, there's going to be a bounce. So now I can look at these. Okay, there's a bounce here, there's a bounce here, but over here it goes straight. So you see how because of the pattern at the x-intercept goes straight, I know it's not going to be this option. So now I narrowed it down to 2. The third thing I got to look at is the 3. So the next intercept, okay, at 3. What degree is this factor? This factor is technically degree 1, right? This factor is degree 1. So what does that tell us? That tells us that at 3, it should be straight. So if you look, over here, it's a bounce, but over here, it's straight. Therefore, I know that C is the right answer. So C is going to be the right answer for A. So by process of elimination, I can figure out what's happening with the function depending on the I have to find the x-intercepts, but 2, I have to find the patterns at the x-intercepts and see which corresponds to each. Hopefully that makes a bit more sense now that we know the patterns. So let's look at the other questions. So we know C is fully out of it because we already got that. Okay, let's look at part B. B says we have the same x-intercepts. So one at -1 and one at 3. But we know that because they're both degree 2, we know we got 2 bounces. So there's only one function that tells us this, and that's this function, A, because it bounces off this and it bounces off this. Therefore, this one is going to be A. Because all of these, this is straight and a bounce, and this is straight, 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 straight. Okay? So we know from that, we can draw the conclusion that A is the answer for part B. Okay, let's look at part C. Part C has -1 and 3. So this is -1 and 3. But it's the reverse. For this one, it's degree 1. But for this one, it's degree 2. So what does that tell us? For the degree 1, at -1, it's going to be straight. But at 3, it's going to be a bounce. So if I look at this, at -1, it's straight. And at 3, it's a bounce. Therefore, I know that this is going to be B. And then, obviously, by process of elimination, we do know that this is going to be D. However, we can just double check how that works. This one has 4 intercepts. X equals 0, x equals -1, x equals 3, and x equals 5. So that means 0, -1, 3, and 5. So we know that for sure, based off the x-intercepts, we know that it has to be D. But also, let's look at the patterns. This is degree 1, this is degree 1, this is degree 1, this is degree 1. Therefore, they're all straight, which makes sense. Straight, 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 straight. So the reason why these questions are important, guys, is you want to understand, 1, what the x-intercepts are, and what are the degrees. So the degrees of the x-intercepts is what's going to tell us. So this is degree of the x-intercepts. That's what's going to tell us what pattern. And then based off the pattern, we'll know how the behavior of that function is corresponding to that x-intercept. So is it a straight? Is it a bounce? Is it a swivel? Is it a prolonged bounce? Is it a prolonged swivel? So these are the first types of questions you guys are going to get when it comes to understanding how to match. Let's look at another type of question. This question is saying write an equation. So this one tells us the graph, and it tells us, okay, how do we write an equation from that graph? These questions are actually really easy when you really understand how to do them. So we know that functions in factored form are going to look like this. They're going to have an a value, and then they're going to have some factors. And the factors are going to correspond to the x-intercepts, right? So this is one thing that a lot of people forget. This is the a value. You always have to include this when you're doing your function in factored form. If you don't include the a value and you only include the x-intercepts, you're going to get the question wrong. So you need the a value. But first, what we're going to do is we're going to start off with the x-intercepts. So if I look at this, I have an x-intercept at -3, 2, and 5. So that means this is going to be x plus 3, this is going to be x minus 2, and this is going to be x minus 5. So I automatically got those x-intercepts from these. So that goes there, that gave me that, and this gave me this. But the second thing, getting the x-intercepts is not enough. I actually have to find what is the pattern at that x-intercept so I can match the corresponding degree. If I look over here, I know it's straight. Here, it's straight. Here, it's straight. Therefore, if all 3 of them are straight, then they're all going to be degree 1. If I had a bounce or a swivel, it may be a degree 2 or degree 3, or even a prolonged bounce or a prolonged swivel, it would be degree 4 or degree 5. But because these are all 3 of them are straight, just by looking at the graph, I know that they're all degree 1. So the question is, okay, we got our x-intercepts. How do we find the a value now? How are we going to find the a value? Well, the way we do that is we have to use this point. We have to use the point to find the a value. So what we're going to do is we're going to take that point and we're going to plug it in. And we're going to say 8 is equal to a, 1 plus 3, 1 minus 2, and 1 minus 5. And then we're going to solve for a. So 8 equals a, that's 4, negative 1, negative 4, which comes out to 16. 8 equals a times 16. And then I divide both sides by 16 to isolate for a, and I get 1 over 2 is equal to a. Now that I got my a value as 1 over 2, I can rewrite the function as 1 over 2 x plus 3, x minus 2, and x minus 5. So this is my final function. So as you can tell, guys, just by finding the x-intercepts and the degrees, and then I take the point, I plug it in to find the a value. And it's that simple. Let's look at this question. Now, I won't do this question fully, but I want you guys to understand exactly how I'm doing this question. So the first thing that I would do is I would take the function and I would say it's a, and then I have, where are my x-intercepts? 1, 2, I have 3 x-intercepts. Now when I look at these x-intercepts, I know that this is going to be x plus 1 for the first guy. For the second guy, it's going to be x minus 2. And for the third guy, it's going to be x minus 4. But I also need to know what degree it is. If I look at this, I have a bounce, so therefore it's 2. Here I have a straight, and here I have a straight, so these are both 1. And now, all I got to do is I got to look at this point, 1, negative 12, and I got to plug it in my equation, and then I can solve for a. And then once I get the a value, then I'm pretty much good from there. So we can actually do it out. Negative 12, a, 2 squared is 4, negative 1, negative 3. Negative 12 is equal to a times 12. And then I can divide both sides. So I'll get negative 1 is equal to a. Now that I got negative 1 equals a, the function is going to be negative 1, or I don't even have to put the negative 1, I can just put negative, x plus 1 squared, x minus 2, and x minus 4. And this would be my final answer. So understanding how these patterns work, guys, is going to be really valuable when the polynomial function is in factored form. What we really got to do is know the pattern. Not just understand the x-intercepts, right, but know the degree, because the degree will tell us what the pattern is around the x-intercept. So this, guys, is the most important thing. And if you can really understand this, guys, your lesson is going to be really easy. You're going to be guaranteed marks on the test if you know how to do this correctly. So keep practicing. If you guys have questions with regards to this unit, feel free to drop it in the comments. I'd love to answer your guys' questions live and, give you guys more support. If you guys haven't subscribed to the channel, feel free to subscribe to the channel. Share this channel to, your friends or people who are taking the course with you. It'll help us really grow this channel, and I'll see you guys in the next video.